In Part 8 of our lesson on applications of vectors, you will learn how to solve problems involving airspeed, ground speed, and bearing. In this example, we are told that a pilot flies an airplane at an airspeed of 215 miles an hour. Let's start taking stock of what we have. Airspeed is equal to 215 miles per hour. The wind blows from the west at 45 miles an hour. So let's think about this. If the wind is coming from the west, then where is it blowing to? If it's from the west, the wind has to be blowing to the east. So the wind is to the east at 45 miles an hour. Next, we're told that the pilot wants her resulting ground path, which is also called the tracking, to be on a bearing of 108 degrees 25 minutes. So that's the ground path. (108 degrees 25 minutes). We have to find the bearing that the pilot should fly, which is the bearing she needs to point the nose of the airplane while flying in the air, and find the resulting ground speed of the plane. So let's get started with our drawing here. Suppose the pilot is here. Now we know that she wants her resulting ground path to be on a bearing of 108 degrees 25 minutes. So draw a dotted line to the north, and we know we would turn through an angle of 108 degrees 25 minutes, and that would be the vector of the ground path. Now this is not the direction that she points the nose of the plane. This is the resulting ground path that she travels once she points the nose of the plane in a direction and then the wind pushes her. This is going to be the resultant in our diagram. So let's mark this vector R for resultant, which is the ground path. Now we know that the pilot is experiencing wind. Since it's from the west, it's going to the east at 45 miles an hour. 45 miles an hour compared to the speed of the plane is much less, so when we draw our vector, we will draw a smaller vector. So maybe that's the wind going 45 miles per hour. Now the pilot wants to fly along this path. If she pointed the nose in this direction, though, the wind would push her off course and she would actually end up over here somewhere. So to counteract for the wind pushing her to the east, she would have to point the nose of the airplane this way. So that the wind would push her to the east and make her end up on the path that she wants to travel. So this would be the wind at 45 miles per hour. Now remember, the ground path is the resultant here, and we can see that our parallelogram is almost drawn. Let's dot in this last side. Her airspeed is 215 miles an hour, and her airspeed is the vector for where she's actually pointing the airplane. So that's here, 215 miles per hour. So you can think of it as though she were pointing the plane this way at 215 miles an hour, and then the wind pushes her this way, so that her actual resulting ground path is the path she wants to travel on right here. So let's start finding some angles in this picture. We know this is to the north, and this is to the east, and we know that north is perpendicular to east, so this would be a right angle. So then to find this angle in our picture, all we would need to do is subtract 108 degrees 25 minutes minus that right angle, which is 90 degrees. The 25 minutes comes right down. 8 minus 0, 8 degrees. 10 minus 9 is 1. So this angle is 18 degrees 25 minutes. Now this is the vector for the wind, and this is its opposite side, so that's parallel and equal in length. So if these two lines are parallel, we can use the resultant ground path as the transversal. Then we have a pair of alternate interior angles. So if this is 18 degrees 25 minutes, then that means this angle will be 18 degrees 25 minutes. We have two sides in our triangle and a non-included angle. So we are going to have to use law of sines. So let's call this angle right here alpha. Now, using law of sines with only one known angle means the ambiguous case. However, alpha is opposite the side whose length is 45, and we already know that the 18 degrees 25 minutes is opposite a larger side of 215. So since the 18 degrees 25 minutes is acute, we know alpha will be even smaller, and so it is guaranteed that alpha will be acute. So we can use law of sines without worrying about the ambiguous case. Then the sine of alpha divided by its opposite side, which is 45, is going to equal the sine of 18 degrees 25 minutes divided by its opposite side, which is 215, cross multiplying the 45 up to the right hand side, we get sine of alpha is equal to 45 times the sine of 18 degrees 25 minutes divided by 215. So the sine of alpha is equal to, let's get this in our calculators. We have 45 times the sine of 18, hit the degree symbol, 25, we've got to get minutes, close the parenthesis, divided by 215, and we get 0.06612, etc. So you know what we're going to do. We'll store that in memory location A. So store A. Now we have to take the sine inverse of the sine of alpha is going to equal the sine inverse of that number we just stored in A, which is the 0.06612, etc. The left-hand side becomes alpha, and the right-hand side, we do second sine inverse, memory variable A, and we get 3.791, etc. We are told that we have to round our angles to the nearest minute. So we know that alpha is going to equal 3 whole degrees, and we will need to multiply the decimal part here by 60. I think the easiest way to accomplish that is to just subtract 3 from the answer you have in your calculator there, so you get the decimal part, and then say times 60, and rounding to the nearest minute, we get 47 minutes. So now let's put that in our picture. Now we have to find the magnitude of the ground speed here on the resultant. So that means we are going to need to know its opposite angle in here, this angle. And we can use the triangle sum theorem to get there. We know that we have 18 degrees, 25 minutes, plus 3 degrees, 47 minutes. Now if we add those, 5 and 7 gives us 12. Carry the 1, we get 4, 6, 7. So that's 72 minutes. 8 plus 3 is 11. Carry the 1, 1 and 1 is 2. Now we can't leave this answer like this because we have more than 60 minutes. So we've learned that we're going to subtract 60 minutes from this and add 1 degree here. So this becomes 22 degrees, 12 minutes. Now that's the sum of these two angles of the triangle. And we know that to use the triangle sum theorem here, we're going to subtract that from 180. So now we're going to do 180 degrees minus 22 degrees 12 minutes, because that's the sum of the other two angles in the triangle. We will need to borrow, so that 180 degrees becomes 179 degrees 60 minutes. 60 minus 12 is 48 minutes. 9 minus 2 is 7. 7 minus 2 is 5. And we bring down the 1. So now we know this angle in the triangle is 157 degrees, 48 minutes. Now we're going to be able to find the magnitude of the resulting ground speed. So we can use law of sines here. To say that the magnitude of r divided by the sine of its opposite angle, which is 157 degrees 48 minutes, is going to have to equal. We have a couple choices we can use for the other ratio. However, we know that this angle, 18 degrees 25 minutes, is exact where the 3 degrees 47 minutes was rounded over here. Remember, to get that 18 degrees 25 minutes, we started from a given and subtracted exactly 90. So since this 18 degrees 25 minutes is exact, let's use the 215 side with the 18 degree 25 minute angle. So then the right hand side is going to be 215 divided by the sine of 18 degrees 25 minutes, cross multiplying, we get that the magnitude of r is going to be 215 times the sine of 157 degrees 48 minutes divided by the sine of 18 degrees 25 minutes. So then the magnitude of r is going to be, we take 215 times the sine of 157 degrees 48 minutes and divide that by the sine of 18 degrees 25 minutes, and rounding to the nearest mile per hour, we are going to get 257 miles per hour. Now we also had to find the bearing that she needs to point the nose of the plane. We know that the bearing from north to the resulting ground path needed to be 108 degrees 25 minutes, and we can see that this angle right here is 3 degrees 47 minutes, so that's how much more she needs to point the nose of the plane to get to this vector. So let's add those two. We have 108 degrees 25 minutes that we're going to add 3 degrees 47 minutes. 5 and 7 is 12. We get 7. So there's 72 minutes. We know we're going to have to reduce that. 8 and 3 is 11. So that 1 comes down. 1. And we've done this before now. We have to subtract 60 minutes and add 1 degree here. So 72 minus 60 is going to be 12 minutes, and 111 plus 1 is going to be 112 degrees. So now we're ready to write our answer in sentences here. We could say the pilot should fly on a bearing of 112 degrees, 12 minutes, and her ground speed will be 257 miles per hour.